The most ancient, least expensive, most abundant, and most environmentally friendly construction material on the face of the earth is the earth. One of the earliest and most prominently used substances by people since the Stone Age until today, currently over 70% of constructions in the world are done using earth. With urban population growth, lot sizes for houses have been reduced, as have the sizes of the houses themselves. Thick walls made of adobe, rock, rammed earth, and straw bale are therefore less efficient or functional for our cities, and have been largely relegated to small rural communities and countrysides, where the cost of land and housing taxes are lower. In the last 150 years, Portland cement, cement blocks, and fired bricks are the main materials that have been replacing more natural means of construction. Unfortunately, this has come at a very high environmental cost. These involve extremely high production of carbon dioxide and other greenhouse gases. The extraction phase and processing of primary materials usually involves mining of industrial rocks and minerals using open pit mines. The production of fired bricks requires fertile earth from the upper soil horizon, which leads to an increase in erosion and desertification. And very importantly, it causes a reduction in soil suitable for food production. Of all human activities, construction is, without doubt, one of the most environmentally impactful. Before the rise of cement and bricks, building materials were natural, extracted from the local environment, and adapted to the conditions and microclimates where building was actually taking place. With this change came a greater increase in the distance between the location where primary materials are obtained and where they are used for manufacture or construction. It also brought about larger depletion of localized natural resources, as well as an increase in the emission of contaminants derived from the construction industry. Add to this the increased amounts of waste from construction and demolition, and the energetic and environmental costs that this represents. The manufacturing and processing phase of cement and bricks releases large emissions of carbon dioxide, suspended solids, SO2, and other gases, and consumes incredibly high amounts of energy. Carbon dioxide is one of the most significant greenhouse gases playing a role in climate change, and its release comes from the conversion of limestone to lime during cement production, from fuel combustion in the kiln, and from power generation. Manufacturing Portland cement requires combustion of materials at over 1400 degrees Celsius, while bricks are fired at over 1000 degrees Celsius. Timber and gyprock continue to be the most popular options for construction in some countries. But with the overexploitation of our woods, deforestation, ever-increasing forest fires, and conversion of forests due to climate change and conflicting land uses, these materials are at their limit, both environmentally and economically. Statistically speaking, it can be said that the construction sector and the subsequent energy requirements of these constructions are responsible for 50% of natural resource use, 40% of energy consumed, and 50% of total waste generated. It's been just over 50 years ago that Raul Ramirez from Colombia invented and patented the Sinvaram, one of the first and most popular machines to make high-resistance pressed adobe. Stabilizing the soil with 10% Portland cement, he was able to make blocks only slightly wider than fired clay bricks, but with equal or greater resistance. Thanks to this invention, the path towards using earth as an alternative construction material for cities was renewed, and dozens of block press designs using levers were developed based on the principles of the Sinvaram. In 1982, the engineer Thomas Geith and his team developed an improved press, patented as a CTA triple block press. As the name suggests, it made 3 blocks at a time rather than just 1, or up to 1,500 blocks per day. While various block press initiatives were developed worldwide at the beginning of the 20th century, not all of them had such significance. A little under 2 decades ago, the production of modular pressed earth blocks, also known as male-female, interlocking, or Lego-type blocks, began to make inroads. These reduced the cost of construction up to 70%, as skilled labour for bricklaying and construction was no longer required. In construction, using these types of blocks is much quicker than it is for flat blocks that require mortar. In addition, some are designed to be resistant to earthquakes and hurricane-force winds. There are different types of interlocking blocks, generally divided into males and females, and 2 types of interlocking pressed earth blocks, those that are solid and those with holes. A further development was the manufacture of brick presses using hydraulic systems to compress the bricks, in place of the lever in the original design. Based on our research, the most advanced designs of interlocking blocks are those from South Africa, India, Brazil, and ours from Mexico, Canada. Ecoblock construction system from the earth. This construction system presents multiple benefits relative to the best on the market. After over 15 years of research and experimentation, we've achieved interlocking blocks and block presses that are qualitatively superior to what is available. Ecoblock is a construction system based on high-resistance compressed earth blocks. They are self-assembling, i.e. male and female type blocks like Lego, and don't require advanced construction knowledge to assemble. They are resistant to earthquakes and hurricanes, contain vertical and horizontal holes or tunnels, through which cables and tubes can be passed, as well as rods or bamboo, steel wire, cable nylon, or carbon fiber, to give greater resistance to the buildings being constructed. To make pressed ecoblocks, the earth is stabilized with 5% Portland cement, or ecological cement, lime, or polymer dissolved in water, resulting in production costs of only pennies per piece. One very important point is that the production of ecoblocks, unlike fired bricks, do not require fertile soil. Rather, they use soil from the deeper horizons.
Contamos con un diseño de prensas manuales e hidráulicas que optimizan y multiplican.
We have designs for manual and hydraulic block presses that optimize and multiply the energy put into the system, increase efficiency of manual labor, and reduce the time required to manufacture ecoblocks. They are based on designs that optimize all structural components and are simple both to operate and maintain. We have designs for manual lever presses that make 4 or 6 blocks at a time and do not require a great deal of force to work efficiently, thus making them suitable for any man or woman to operate. The hydraulic presses make 4, 6, 8, or 32 blocks every 58 seconds. Another advantage of our machine designs is that blocks receive compression on both sides, not just one. This doesn't only use energy more efficiently, it also gives better block compression. One element common to all other block presses, including our original designs, is that blocks are compressed on one side only, resulting in the side of the block that has been pressed being stronger than the block's opposite side. Some block presses are thus designed to compensate for this difference by using an excessive amount of energy to overcompress the side of the block receiving the pressure, so that the difference between the 2 sides of the blocks isn't as notable. Another significant difference or improvement in our designs is that most of ours require the labor of only 2 or 3 people. This is thanks to an automated system, whereby all of the blocks that are pressed are automatically lifted and placed in the area where they're to be dried or cured. Other machines require people to hand carry the blocks one by one. You can imagine how much manual labor that would require, particularly for presses that are making 4 or 8 or more blocks at a time. We invite you to watch our other videos, and thank you for taking the time to watch this one, as well as for any comments, questions, or feedbacks you may have.